I'm going to teach you everything your teacher doesn't want you to know about the central limit theorem. All right, folks, let's look at this first problem. A sample of size 60 will be drawn from a population with a mean 31 and a standard deviation of 6. So in this question, what they want us to do is use our technology, right, our TI-84 calculator, and we're going to do the following things. So part A, we're going to find the probability that the distribution, the sample distribution mean, will be greater than 30. Notice, we're not trying to find the probability that some value x is greater than 30. What separates this from our last section is now we're trying to find the probability of this sampling distribution mean. Alright, so we're trying to find the probability that x bar, not just x, right? Not one single value, but the mean of this sampling distribution is greater than 30. So because we're not looking for one individual value here, this changes the dynamic of everything. Alright, so what we're going to have to use, and you should have read up on or watched the previous video, we're going to have to use the central limit theorem. Alright, and make sure you check those conditions of when can we use the central limit theorem. Alright, so here's our explanation. Alright, so we want to find the probability that x bar, not x, but x bar will be greater than 30. Alright, so let's go ahead and sketch our normal distribution. Alright, and we're going to go ahead and we're going to put all the information that they give us. So the mean, right, the population mean is 31. And what we're interested in is the probability, right, this area. We're trying to find all this area here when, not x, but when the sampling distribution mean, which is x bar, is greater than 30. So that's what we're trying to do here. Alright, so it's going to be very similar to what we did before, with this little difference of, alright, here it comes. To find the probability that x bar will be greater than 30, we're going to use normal CDF again, just like we did before, right? So you press second bars to access the distribution, and then make sure you select normal CDF. Alright, and by looking at our distribution here, remember this is our lower, right, because that's where we start shading, and our upper, you're shading all the way to the end as much as you can. So that's why our upper we do 1E99. Alright, so go ahead, I'll give you a second to jot that down.
8 semesters later.
Alright, your second is up. So just like we said, everything's pretty much going to be the same. And the only difference I want you to highlight here, let's highlight this, is take a look at the standard deviation that we're going to be using because of our central limit theorem. So what it tells us is whenever you're entering the the standard deviation of this sampling distribution, the way we approximate it, the way we calculate that, is you take that population standard deviation that they gave us, and we divide it by the square root of whatever our sample size is. Alright, so for this example, the population standard deviation that was given was 6. Alright, and then our sample size was 60. So we're not going to round it, we're going to enter it into our calculator exactly like that. So just like you see this fraction, that's how you enter it into your program. Alright, and what that's going to do is that's going to give us, let me highlight this area that we're interested in. So that's what this program is going to give us. So whenever you use normal CDF, a reminder, this program gives us an area. And what your job is you tell the calculator, where do you want me to start and where do you want me to finish? All right. So let's see what we get. Let's actually plug this in. All right, so go ahead and plug that into our calculator, right? And we see that we end up with that area of 0.9016. And we're rounding this to 4 decimal places, 0.9016. So that represents that area that we discussed earlier. So this was 30, our mean was 31. So that 90/16 represents that area right there. So we conclude that the probability of x bar, right? We conclude that the probability of x bar will be greater than 30, right? So the probability that the probability that x bar will be greater than 30 is all this area right here, which was about 90%. All right. So there's example 1. Let's take a look at our second example. All right, let's look at problem number 2 here. Find the 85th percentile of x bar. Again, not x, x bar, the sampling distribution mean. All right, so first thing we do, we sketch that normal distribution, just like we always do. And 85, check this out. When we're talking about the 85th percentile, we keep shading. Maybe I should have did a different color. We keep shading until the area that we shade represents more or less 85%. Actually, I wonder if I could rewind this for you. So notice, if I were to shade and if I were to stop right there, notice that's our midpoint, that's our halfway point. So this area is 50%. So I need to shade a little bit more, right? So that's why I kept going. And I shaded this area too. Maybe I might move a little bit to the right, maybe a little to the left, but it just gives us an idea so that when we find this x bar, we have a really good idea that this value should be greater than 31, right? Because it's to the right. So if we get an answer of like 25, we know we jacked up somewhere. All right. So we're going to work with this area. So make sure you tell yourself, okay, this area is 0.85. So what's given, and that's what you always have to understand, is what is it that they're giving us? They're giving us an area. And they want you to find this variable here, right? So because they give us an area, let me move myself out of the way. Because they give us an area, in your program, what you're going to be using is you're going to be using the inverse norm. All right. And to find it, remember you hit second vars and then you select inverse norm on your calculator. Okay. But just like before, what we're going to be entering is we're going to need that area. We're going to need that mean. And we're going to need the standard deviation. And because we're finding x bar, right? We're comparing it, we want to find the percentile of x bar. What we do is we use our central limit theorem again, which says you take the standard deviation, right? Let me write that down. You take that standard deviation and you divide it by the square root of n. So again, that's the same thing that's happening there. So let's actually take a look at our calculator to see how we plug this in. All right, so we got all our information listed up here. So let's go ahead and use our calculator and plug this in. So we hit second vars. So we hit second. Oops, gotta turn on my calculator first. So we hit second, and then vars, which is right here. And what you're gonna see is your options come up, and you want number 3. So let's go ahead and click number 3. And click number 3 here. And when you click number 3, you have to tell your calculator the area. And this is where, let me draw the picture once again so we make sure we type in the right area. So alright, this is what our distribution looked like. We're trying to find X bar. And they gave us the 85th percentile. So notice this area that I'm shading is to the left. If your calculator doesn't ask you, like mine does, the left, center, or right, what your calculator is assuming is that this area is going to be the left. So what you always want to enter into your calculator, if yours isn't as nice as this one, is you enter in the area to the left. Alright, so if they give you the area to the right, just do 1 minus that area, and that's what you're going to plug into your calculator. So our area, we said, is 0.85. The mean we're going to use is, they tell us up here, is 31. The standard deviation that we're going to be using is 6 divided by the square root. The square root of 60. And make sure that you tell your calculator it's the area to the left. And let's go ahead and paste that in. So if you have an older calculator, you're going to have to do all this manually. And so what you would do is you would put the area, the mean, and the standard deviation, and don't worry about the left part if you have the older calculator. Hit enter, and boom. What we just found is we found our X bar value. So X bar is approximately 31.8. So just make sure you read the instructions in terms of how much they want you to round to. Alright? So in conclusion, we could say that the 85th percentile is 31.8. Alright folks, hopefully this video is helpful. Don't forget to smash that thumbs up button. Go ahead and subscribe, and we'll see you in the next video.